Hi guys, welcome back. Hopefully everybody's having a good day. Today we're going to be talking about solving quadratics. So we've done a lot with quadratics in our review. We've practiced factoring them, we've graphed them. So now we're going to talk about how we can solve them algebraically. So when we solve them, what we're finding is where they cross the x-axis. We're finding those x-intercepts. So if we want to solve this guy by factoring, the first step would be to get everything to one side. And we want to try and keep the variable squared positive. So the easiest route here is going to be to subtract 3m from both sides. So we subtract 3m. So now we have m squared minus 3m. We want to write it in descending order, so our a, our b, and our c are all in the right order. Minus 28 equals 0. So with this one, remember, we're looking for two numbers that multiply together to give us c, but add up to be b. So we've got to find two numbers that multiply together to give us negative 28, but add up to be negative 3. What do you think those are going to be? All right, so if you said negative 7 and positive 4, that is exactly correct. They multiply together gives negative 28 and add up to be negative 3. So now our last step is just to solve both of these binomials, and this will tell us where this thing crosses the x-axis. Oops, I guess I should do the math first instead of just writing the answer. So we would set m equal to 0. Now we just got to add 7 to both sides here to undo that, and we get m equals 7. And we got to subtract 4 from both sides for this one, and we get m equals negative 4. And that would be our two solutions. All right, so here's another example, and hopefully you're looking at this like, oh, we're going to have to do the box method, because notice that a value is something other than 1. So let's start with our first step. So I'm sure you guys are already adding the 23a to both sides. Whoops. Can't read that. 23a. So that gives us 6a squared plus 23a plus 21 equals 0. So with this one, we're going to do this one just a little bit differently, because we're going to do the diamond first. So remember, with your diamond, the top is the a times the c. So what we got, 126a squared, but I'm just going to put the 126 here. There's not enough room. And then down here, our b goes here, 23. So we're looking for two numbers that multiply together to be 126, but add up to be 23. So what do you guys think those are? All right, so said 9 and 14, right? That would be correct. So those are the two numbers that we need to use to factor. So I'm going to come up to the other side now and make my box. You can make your box a bunch of different ways. This is how I always do it, though. I always put my first term in the bottom left, last term top right, and then I put the two numbers I came up with in either one. It doesn't matter. So 9a and 23a. I'm sorry, 14a. Gotta erase that, huh? All right. So now we got to factor out what they all have in common. Well, 9a and 21 both have a 3. 6a squared and 14a both have, looks like, a 2a. 6a squared and 9a both have a 3a. And then 14a and 21 both have a 7. So that means this factors to 2a plus 3 times 3a plus 7. And we can solve it by setting each one of these equal to 0. So we get 2a plus 3 equals 0. And then 3a plus 7 equals 0. So now we got to work backwards in the order of operations and solve these. So we're going to subtract 3 from both sides. And we got 2a equals 3. And then we're going to divide everything by 2. So we get a equals 3 halves. Well, negative 3 halves, sorry. Got my minus sign. There's our first solution. And then here we got to subtract 7 from both sides. So we got 3a equals negative 7. Divide everything by 3, and we get a equals negative 7 7/3. And that's our other solution. So that's the 2 points where this one crosses the x-axis. All right, so this is kind of a special case. We want to take the easiest route we possibly can when we're solving. So if you look at this problem, notice if we got everything to one side, or actually we don't even need to worry about getting anything to one side right now. We're missing a value here. So if you think about the general form of a quadratic, this is what it looks like. That's a c at the end. Notice we're missing the variable to the first term. So we can solve by square roots when the b value is 0, basically. Makes it way easier and quicker. So let's take a look here. So if we want to solve this, the first thing we would do is try to get a squared by itself. So we're going to add 3 to both sides. And we got 2a squared equals 68 now. Now that's an 8. I got to divide everything by 2. So now we have a squared equals, what is half of 68? 34. Well, how do we get rid of a square root, or square? We have to take the square root. We also need to remember that when we take the square root of a number, we have a positive root and a negative root. So we want to put a plus and minus there. So I'm going to move over to the other side now. So now we have a equals positive and negative square root of 34. So now we just need to simplify this if we can. But unfortunately, well, not unfortunately, I guess, nice that we don't have to reduce it. 34 is 2 times 17, so there's no perfect squares in there to pull out. So we could do decimal approximations to see where this is actually at on our x-axis. But again, this is crossing the x-axis at negative radical 34 and positive radical 34. All right, so here's another example. So this one might be a little more involved. I don't know. Let's see. So what is our first step here? Exactly right. Since there's no b value, we want to subtract 9 from both sides. We're going to use square roots. So now we would have what? 19a squared equals 5,624. So our next step would be to divide everything by 19. So once we divide everything by 19, we get a squared equals 296. All right, so we got to take square root of both sides now. And we got to put a plus and minus here because we got 2 roots. So we're going to have a equals positive and negative radical 296. So 296, we need to see if we can reduce it at all. And again, we can do a factor tree or look for the biggest perfect square. It is totally up to you. I'm going to do a factor tree just because, I think visually on a video that might be the best route for right now. So that is what 1 times 148, and well, 148 is even. So I can divide it by 2 again and get 74. 74 is even. Divide it by 2 again, and I get 37. 37 is a prime number. So it looks like the only thing we can pull out is a 2, because we need 2 of them to get 1 out. So we're going to have a equals positive and negative 2, and then we need to stick the 2 times 37 back in and get 74. And that would be our exact answers for this problem.